Today we're going to do something very interesting. We're going to explain how to make the rotor for a three-phase induction motor in a way which has magnets in it. It's much more powerful than before. Now some companies have done it, but I want people to be able to do it at home. So what I've done here, I bought a three-phase induction rotor for about $60, and this is the rotor it comes with. This big heavy thing that would fit into there like that. And I took it out, and you can see here there's lots of sheets of laminated steel, and there's lots of little copper bars you can't see around the whole thing. But we'd like to build our own and change it. So what I've done here, I've got one here that works. It's very easy to build. It just has 4 parts. We have, here it is. On the outside there's a little bit of copper foil going around it, and then there's 6 copper bars, and there's a little sheet of steel, and inside there are 2 magnets, or 4 magnets, all pointing NS the same direction. Now when we stick this thing in the device, it works beautifully. We'll put it in the device. We come over here, we'll turn the power on and watch it spin. Now that's spinning at 4 Hertz, and you can see it's going around about 4 times per second because of the magnets. Without the magnets it'd be much less powerful. Now to make it even more powerful, we're going to, and remain safe, we're going to put this plastic cover over it, and we'll put a little piece of red tape so we can see how fast it's spinning. We come over here on the light now, we put it on the top. Now we're going to turn the power on again, and you can see it start spinning. Now let's let it spin a little faster. That's 4 times per second. 8, 12, 15, 20 times per second. And just from this little thing we've made. Now we've determined how it works. Now we're going to show you how to build it. Now I've shown you how well this device works, this little copper induction rotor with magnets, and now I'm going to show you how to make one. Anybody can do one in the garage. So first what you need a copper dowel, a wooden dowel. It can be aluminum if you want, and you need a bobbin. Just some sort of plastic bobbin about the right size. You stick on it. Anybody has that. And then you need a piece of sheet iron like this. And inside of it you put some double-sided tape, like these little things, double-sided. And then you need some magnets. Now what I've done is use 4 of these little neodymium magnets, 20 times 10 times 5. These little things were what was spinning the rotor. When you put them in there, you see immediately they'll just stick to the iron really tightly, so it's not hard to get them to stick. And you can see they were sticking here in the same way, just like that, you see? Now if you decide to use for industry, you might want to go to heat stable ferrite magnets, which are like these, which are stable at high temperature. But just for practical purposes, these cost about 50 cents each. I've got hundreds of them here, so you can have all you want, okay? Next thing we do is, we've got our magnets and the iron and the dowel. Next thing we want to do, we want to put these 6 copper bars around. So we have to put more double-sided tape around. I'm just going to put 2 pieces of double-sided tape like that. And you can take the little pieces of green paper off like that. And just for temporarily, you can stick copper bars to it just like that. You put 6 of them. And that's just what we did here. Very simple. Very simple. Finally, we can take some copper foil, which we took from the sheet, just cut with scissors, and just wrap some copper foil around this end like that, and around the other end. And what that does, that lets currents flow from one copper bar to the next, which is essential or helpful for the motor to work. They're shorted, the currents can flow. Finally, we just take some electrical tape, this yellow stuff, and just wrap it around so the whole thing doesn't fall apart. That's what this is, yellow electrical tape. So in summary, it's very easy to build. We've got wooden dowel. We have a piece of iron with 4 magnets stacked inside. The reason you stack them inside is for 2 reasons. First, you don't want them flying out when the rotor spins. Secondly, for this kind of motor, the magnets need to be inside rather than the outside to spin effectively. Then we have these 6 copper rods about 5 millimeters thick. Then we have this copper foil. You can see thin copper foil around the outside, and that lets the current spin. So these 4 parts, if you follow this diagram, you can't go wrong. To conclude our study, I'd like to emphasize how our design here with 4 parts is very similar to what the car company Hyundai in Korea has done. We both have these are copper bars they have around the outside, these blue things. We have our copper bars. They also have copper conduction around the outside like our foil. Inside they have 4 sets of magnets which are color coded north, south, north, south. And we put 2 sets, north, south, because the things are wired a little bit differently. And these white things are all their iron sheets, and we have iron sheets. So, however, it's a lot easier to use our model than this if you're not a car company, if you're building in your garage. You know, you do that in your garage, you need something simpler. So here's our device with the foil, copper rods, iron, and magnets, 4 parts. We're going to put it back into the motor just to emphasize again how it works. So we'll turn it on first 2.5 times per second. And you see it spinning synchronously 2.5 times a second with the 3-phase rotating field. And now we'll go 5 times per second. And you see it spinning 5 times per second as the field rotates around inside the coil. And then here's 10 times per second. And you see it spinning 10 times per second, just like the rotating magnetic field. So this is how you put magnets inside of a copper induction rotor and have it work. It's essential in this thing to have the copper on the outside and the magnets near the inside and iron between them. So this is probably the best design. I've tried lots of them. And then as a final step, we'll look to see what happens when there aren't any magnets there. Now for the final part of this video, I want to demonstrate how important the magnets are for efficiency. You remember the previous motor was spinning at about 2 on the device when it had these 4 magnets in it. 1, 2, 3, 4. I'll pull them out like teeth, and these magnets are gone. So now what we have here, we have the device with no magnets. Same thing. Foil, copper rods, and iron, but no magnets. I'm going to put it into the thing, and there it is. Now I'm going to turn it on, and we actually have to go up to about 10 to make it spin. And it's only spinning 1 or 2 times per second. We have to get up to about 10. Look at that. If we go lower, down by, say, 8, it just barely spins. It won't spin at all. Now you remember with the magnets it was spinning at 1 or 2. So we've got 5 to 10 times more power just by putting the magnets in. We can still spin it up at high speeds like 20. There's 20, but it's still not spinning nearly as well as with the magnets. In summary, the take-home lessons from this video is that if we take commercial 3-phase motors and instead of just using iron with copper bars, which does work but takes a lot of energy, if we include magnets close to the center, just dipole magnet like we've done here in our little model device, copper bars with magnets, and also like the Hyundai car company has done with their subway train that works, copper bars with north-south magnets, then the energy efficiency of this motor should be increased maybe up to a factor of 5 or 10, especially at low RPM, and we can save energy for everybody on Earth.